Hi folks, and welcome to a brief look at the stream editor. You know how it goes. Every now and then you find a problem and the only way to solve it is to go all command line on its arse. This particular problem is with the AvaMedia. As you can see, we've got a number of .ts files in here and they're various sizes. I've just used this for illustration. But when I'm recording a long gameplay video, what it does is it splits the TS files into chunks of 4.2 gig, but it doesn't write a fresh header to each file. So I've got to concatenate all the TS files into one large file before I can process it. So what do? Well, I have a file called join.ts. .sh shell script that I created, and it does a number of things. The first thing it does is take a directory listing and put the output in a file. Now I've labeled the SD card AvaMedia like that with that particular case, so I know that when it's in the machine it's always going to be mounted at that location. So I've asked for a file list. I've used the options -tv, and it's to put the output into a file called ts1.sh. Now, the -t option tells ls to sort the files in date-time order, but it's always newest file first, so I use the -v option to invert it. So what we end up with, if I open another terminal session, is cat videos ts1.sh. You can see that we wind up with a list of files which are in date order, oldest first, because the oldest is going to be the first file in the file structure and the rest of it follows after. Relatively straightforward to that point. Now we come to the SED editor itself. Now, the stream editor, we're putting this in -e mode, which is edit, and this is the pattern that we're going to ask it to match effectively. The input is the list of files that we've generated, and we're going to output to a new file called ts2. Now, the stream editor is one of those things, you know, like you learn to ride a bike. It takes quite a bit of effort, but once you've got there, it's all plain sailing. And the stream editor is something which, you know, you need to have a heavy duty look at, really, because well, it takes a bit of getting used to. Now, the more common format you'll find some of these pattern matches in is if I do my mod to dv, you can see a typical SED command here, and you can see the use of forward slashes. What this is doing is they're acting as a delimiter, basically. But because I actually wanted to use slashes in my command, I had to use something else as a delimiter, so I used %. How does it know what the delimiter is? Well, it typically takes the first character after whatever command you're using within the said command itself, within the overall instruction. So here you can see the first delimiter there, the second delimiter there, and the third delimiter there at the end. Now what this is doing is the first section is what you want to do, the second is what pattern we're matching, and the last is what we're replacing it with. Now, this particular section here, the hat symbol is the beginning of line, the dollar is the end of the line, and the dot star basically covers everything in between. So what we're telling it to do here is match every pattern in the line. So just match the whole line. And what we're then doing is constructing a new command, and the command is to concatenate the file and append it, note the double greater than symbols there, to a file called joined.ts. Now the ampersand here basically represents everything that it pattern matched in the first place. So we go from that. I'm just going to clear this and give you the first one again. So we go from that to this. So you can see we have the commands cat, that location, which we know is going to be there, and it's replaced with every file name, and it will append it to joined.ts. We remove the previous joined.ts, and then we actually tell it to run the program, the sh file that we just created, so it then goes away and executes all those commands. Now, if I go into videos and ask for an ls, you'll see that we have various bits and pieces here. Among them is the ts2 command, and you'll find that it's executable. Now you can handle that one of a number of ways. You can either add in your original command structure a chmod command to make it executable, but what I found is that once you've made a file executable, you can create another one on top of it, and it retains the same permissions, so it retains its executable status. So I haven't got to do chmod plus x every time. So then we are executing that command. Another quirk that we're taking advantage of is when you're appending a file to another file and that second file doesn't already exist, it will create it for you. So now we're just going to run that, we're just going to run these commands, which is basically just going to say, okay, delete the previous one, there wasn't one, fair enough, and we're just going to run that, and what we then wind up with is it goes away, starts to process, and if we switch into that particular location, you'll find that it started to create it. Boom, done. What we'll find that we've got is one file which contains a number of short sections of me messing around, and then jumps around a bit, and then I go and play Superhot for a while. This is the Superhot demo. You can download it easily. It's from 2013. The full game itself is on Steam, and it runs under Linux as well. Take his gun. Boom. Time only moves when you do. I saw Lactobacillus Prime playing this a short while ago, and I downloaded the demo, gave it a bit of a try. Now this one is really hard. You're getting attacked from a number of different locations. You've got to grab the gun and kill these guys before you get shot. The problem is there's bullets coming at you, one from the front and one from the rear. And also there's then other people coming from different directions, like that direction. Oh, and I got shot from another direction. So it takes a while. So, yeah. This is another point where I find mouse resolution adjustment handy. Yeah, but anyway, you can see that we have a number of sections, and this will do another jump in a minute because I kill him, go on to attempt to kill him, and fail dismally. There's one more somewhere, or is that it? Nope, throw the gun away, collect a new one, and then throw him. Oh, there's one behind him. And then we jump cut.
Super hot.
We just jump to the next one. There you go. It's just jumped to the next file in the sequence, and it's managed to concatenate them all together automatically. So the stream editor is pretty powerful. You can use it in your command line scripts to do some pretty cool stuff, and really automates a lot of file name processes. Yeah, I think you can see it in the previous one also, where I did a lot of funky stuff here. I took it to look at every mod file that I've got in a directory, dump that to a txt file, where it found everything with .mod. What was I doing? Yes, I was actually deleting .mod. I was taking the extension .mod off the end of the file names. Then what I was doing was using that twice, I think. Yeah, this is one command here, and what this is doing is where it finds the MOV, because when I'm recording with the usual camcorder, it has files which start with MOV, then you've got 3 different digits which are hexadecimal, then you've got the .mod file extension. So at this point we've taken .mod off the end of the file, and we're pattern matching MOV and then 3 characters which could be 0 to 9 or A to F, and replacing it with this command here, which is triggering the avconv with an input of, note the ampersand here, of that file name. We're setting our resample rates using strict experimental, and we're using that same file name again, but this time with a .mp4 extension. So we're then generating a file which contains loads of commands which convert every .mod file to a .mp4 file with our specified requirements. There's an old one which I adjusted from, because you can see it's remmed out. That one's remmed as well, and then we just execute the out3. So yeah, the stream editor is very useful, it's very powerful. It takes a bit of concentration before you eventually wrap your head around it, but once you do, you're sailing. It is one of those bikes which, if you don't ride it very often, you can forget how it works, and you've got to re-jog your memory. So the one thing that I'd advocate is, when you go through it the first time, is keep a little notepad of memory joggers, so that when you come back to it later, you haven't got to go through the whole process. Just read your memory joggers, and that will get you back into the swing of using SED quite easily, quite readily. Pattern matching itself is quite powerful. It takes a bit of practice to get used to, and sometimes it can vary between different applications on different platforms. Although you'll typically find that the pattern matching for SED is relatively stable across different platforms, Linux, Unix, etc. Some other applications may not adhere to the same pattern matching techniques. So all I can do is say take care, and just take a little bit of time until you get used to it. So, hope that's helped. Bye for now.